For our first example, we're going to find the value of y in each of these equations. If I ask you to tell me the arc sine of 1/2, I know that they want radians because they did not specify, okay, and they put y. If they used a theta, we might would assume they want degrees. If they use a y, they want radians. Most inverse trig functions are done in radians. Basically, what this is asking you is whose sine is 1/2? So which angle?
30.
All right, and we've decided that it's 30 degrees. Because it's positive, we know it comes from quadrant 1, and then we know its reference angle is 30 degrees. But because we want it in radians, we have to know that that is pi over 6. So if they're positive, most people do really well with this, especially the ones that are on the unit circle. All right, let's try this one. I would like to find the inverse sine of -1. Where is the sine value -1? If you're not sure, kind of think about your unit circle. It's either going to be at pi or 3 pi over 2, right?
3 pi over 2.
Let's think about it.
Okay.
So
It's
this one is -1, 0. That's the cosine. This one is 0, -1. So you're right, it's 270 degrees. But we said we're not allowed to go bigger than quadrant 2. So that actually means we have to come around backwards and get that.
So it'd be a negative pi over 2.
It would be a -90 or a negative pi over 2. So you're not allowed to go bigger than 180 or pi. So if you need to get to here, see, this is off limits. You're not allowed to cross through this quadrant. This quadrant's off limits for inverses. So because of that, you have to start at 0 and come backwards to get here, which would bring us to -90, but in radians, that is negative pi over 2. So it's not as bad as you think it is. Like once you kind of start sorting through it, and that's just when you're asked to evaluate inverse trig functions. Other times you're allowed to use those quadrant 3 and quadrant 4 angles. All right, what is the inverse sine of -2? Let's think about it for a second. Do you know anywhere on the unit circle that has a sine value of 2 or -2? No? Okay, so that makes me nervous. If it's not on our unit circle, guess what we have to do? We have to do our calculator. Oh, we have to use our calculator. But you need to be in radian mode. And if it's not on your unit circle, you may consult a calculator. So put it in radian mode and try the inverse sine of -2 and see what happens. Ooh, this is bad. So not on unit circle. And when we, you guys okay? No? Okay. When we consult a calculator, we get an error. Does it say domain error?
Yes.
Yes, we get a domain error. Does anybody know why?
Because it's not in the domain.
Yeah. The original sine function can only spread between -1 and +1. It can't have a value of -2. It's outside of that range of the original and the domain of the inverse.
On that blue chart you showed us.
Right. Okay. So we technically, I don't guess we would say no solution. I guess you could. We could say no solution, undefined, or does not exist. I usually use does not exist for these. I guess we should consult your book and see what they say. Does anybody want to do that? Does anybody have their book open?
I do.
See how your book answers that question. I would typically say does not exist or not defined. Let's pause and check. But usually, unless it says in the original, unless it says solve, we only use no solution when it says solve for something. Typically, because only you would have a solution to it. Does not exist. Yeah. Let's go with that. So let's go with does not exist. Any questions about these three? Okay. So if it's not on the unit circle, you're going to go to your calculator. But if it's outside of the domain/range, range of the original, domain of the inverse, then you know you're going to get a does not exist. So you're going to get an error there. All right. Be certain that the number given for an inverse function value is in the range of the particular inverse function being considered. Okay, first off, that means make sure that you're in the right quadrant. Do not give quadrant 3 and quadrant 4 angles. You can't use quadrant 3 at all. And if you give a quadrant 4, you have to give it as a negative because you're not allowed to go over pi or 180. That's where a lot of mistakes happen. People just forget and they get in a hurry and they give it off of what we memorized from the unit circle rather than coming backwards through the negatives for quadrant 4. Here's example 2. And I'm going to pause right here and give you a chance to try these two together. Are we in radians or degrees? Radians, because it doesn't specify and it says find y. X's and y's typically are used for radians. Okay, so for example 2, we have the first part, y equals the arc cosine of positive 1. Where is cosine positive 1 on the original unit circle? 0 degrees and 0 radians, right? 360 degrees and 2 pi radians, and that goes on forever, right? Where else? Anywhere else? No, just those and the ones coterminal to it. Which one is acceptable? So we basically have decided this occurs at 0, 2 pi, negative 2 pi, and all the others that go with it, right? Yeah. Which one am I allowed to use? 0. Yeah, you are not allowed to go bigger than pi, and you're not allowed to go smaller than negative pi over 2. So they always have to be between negative pi over 2 and pi for radians, and negative 90 and 180 for degrees. So if you're having to choose between those different values, you choose the one that happens between there, which is 0. So the answer to this one is 0 radians. For part B, we want to evaluate inverse cosine of the negative square root of 2 over 2. If cosine is negative, it's going to come from quadrant 2 or 3, but 3 is off limits with inverses. If you see this symbol, an arc symbol, or the inverse little exponent notation right there, if you see that, quadrant 3 is off limits. So 45 degrees, which is going to be something pi over 4. And because it's in quadrant 2, it's 3 pi over 4. Make sense? Yes? Okay, let's see if that works out. I know that my answer has to be somewhere between negative half pi and positive 1 pi. Is that in between negative half pi and positive 1 pi?
Yes.
Yes. It's close to pi, but we haven't gotten there yet.
So why is it positive rather than negative?
The angle is always positive unless you give it from quadrant 4.
Okay.
The only time you would have a negative angle is if you because we're not allowed to go into this quadrant at all. Okay, this one's off limits. If I need to get over here, the only way to get there is to go positive.
Okay.
If I tried to go negative, I would have to come through that quadrant to get there. So for quadrant 2, you'll just give the one you memorized from your unit circle. The only ones that are going to be weird are the quadrant 4 ones.
Okay.
Okay. And guys, you can check this in your calculator. If you're in radian mode, try this. Inverse cosine or second cosine of negative square root of 2 over 2. Now it's going to give it as a decimal, but you could match it to your answer. So if you tried that, you did inverse cosine of negative square root of 2 divided by 2. What does it tell you?
2.3.
2 point what?
356.
2.356 radians. And then if you type in 3 pi over 4, that's what that should equal. Does it?
Yeah.
Yes. So you can check these. That's a good thing, that you can usually check most of these. So please do. And your calculator can be trusted for everything except for cotangent. Your calculator has major issues with cotangent, but we are going to talk about that later. Okay, now we want to try some of these in degrees. And personally, even though it's not used very much, I think it's easier. I tend to think better in degrees. So let's try this. Let's try to find the arctangent of 1. Because it's using theta, we're going to be in degree mode. Where's tangent 1? What reference angle? 45 degrees. Well, because it's positive 1 right here, I'm going to just give it straight out of quadrant 1. So quadrant 1, which would be 45 degrees. So it's really easy when they are positive. Now here's where things get a little weird. If I ask you to find the degree measure where the inverse secant is positive 2, I don't have my secants very well memorized. So what I do usually is I say this is the same as the inverse cosine of 1/2, right? Because if secant is 2, what's cosine? 1/2, yeah. And I know because it's positive that I'm in quadrant 1. So it must be what angle? 60 degrees, yeah. How would you check that one in your calculator? Do you guys remember how to?
Yeah.
1 over
1 over
secant,
second.
second secant.
When you're looking for an angle, you always use the second button first. So you would have to do second,
1
then
over
cosine, then the 1 over whatever you're trying to find it for. Just like I have written right here, right?
So yeah,
That's why you have to do it that way. You can't type it in as a secant. You have to convert it to a cosine and then type it in that way.